All right, so yesterday we took a look at the first two math properties. Today we're going to take a look at the last two properties. So the first one we're going to look at is the identity property today. And if you look in front here on the screen, you should see SpongeBob. So this is SpongeBob right here, and I'm going to ask you a couple questions. So if I do this, who is it? SpongeBob, right? Hasn't changed. What if I give him glasses? It's still SpongeBob. What if we give him a mustache? It's still SpongeBob, right? So that's kind of the basis of identity, that your identity is who you are. What you put on doesn't change you underneath. You're still you. The same in math. It's a similar idea. The original number stays the same. It's still a number. So there's two kind of different definitions, but very much the same. One with property of addition and one with multiplication. So the identity property of addition is when we take a number and we add on 0, we still end up with the same number. So it's kind of like SpongeBob. We put on a hat, we end up with SpongeBob, right? But for addition, we would add 0. That's the only number we can add and still keep that number the same. So identity property of addition is a number plus 0. Now, when we're looking at multiplication, if we multiply by 0, we'd end up with 0. So that doesn't work. So identity property of multiplication says a number multiplied by 1 stays the same. So, for example, our math example here, 10 times 1 is still 10. So again, identity property takes the original number and has it stay the same. If we're looking at addition, we're adding on 0. If we're looking at multiplication, we are multiplying by 1. Now, the last property should be more familiar with you because we definitely just looked at it in using it to simplify expressions. So it comes from the word distribute. And then here you see my lollipop. And if you think of distribute, and I told you to distribute to those 3 friends again, what would you do? Well, you take that lollipop and you share it with everybody so that everybody has one. It's the exact same idea in math. We're going to take the number out front and we're going to multiply it by every term inside of the grouping. So it's basically a math property that, again, has one number out front and we share it with both numbers inside of the grouping. And we multiply when we do that. So we have -2 and we multiply it. And again, this is what we looked at when we were simplifying the algebraic expressions, but we have -2 and multiply by x and get -2x. Then we take our -2 and multiply it by a +7, and we end up with a -14, which, again, buddied up with that first term, looks like a minus sign. The distributive property takes that -2 and it distributes it through multiplication with both terms inside. You can also see it written the other way. This just kind of has my distributive portion over here, and here's kind of like in the same sense my answer, but they mean the same thing. Okay, so again, you'd be looking at the distributive property means that, hey, you can take this 4 and multiply with x and we get 4x, and then we take the 4 and multiply it by -2 and get -8. So again, distributive property should be the one that you're most familiar with. We just looked at using it to simplify expressions. All right, so taking a look at all 4 together, it is kind of tricky. So if you remember commutative, just as a kind of a quick review, we'll do this together. Commutative is where we're looking at the order, where we drive from, my house to your house and then your house to my house. They're the same distance, right? So the order of numbers can switch. Associative has to do with grouping, how we group things together. Distributive, we look at, we have a term with parentheses. And then identity keeps it the same. Again, identity, you're either plussing it with 0 or you're multiplying it by 1. So those are kind of the short and sweet definitions. So if we take a look at all of these, and again, if we're live in class, we're going to go through all of them. If you're with me here online, hopefully you can kind of follow along and just double check. So take a look at A. What do you think A would be? Hopefully you're thinking distributive. Here is my distributive portion. -4 times 3x gives me -12x. -4 times -5 gives me a +20. So this is going to be a yellow. It's going to be distributive. I'm just going to go through and highlight given the colors that we have down here below. All right, taking a look at B. What do we think about B? What property allows that to be a true statement? It would be order, right? X plus 12, 12 plus X. So if you notice the order is switching, but again, creates an equivalent or equal expression. Okay, take a look at C. What do you think? Okay, C would be an example of an identity property. 3 plus 0 is indeed 3. So you're keeping that number, that 3, adding on 0 doesn't do anything, keeps it a 3. That's identity. All right, look at D. D is also identity because we have a number and it's equal to 12 times 1. So 12 is my original number. We multiply 1 and I still get 12. All right, look at E. All right, E, hopefully you said that has to do with order. I'm sorry, with grouping. X, Y, Z on the left, the order is the same, X, Y, Z, but what you notice is the groupings are different. All right, take a look at F. This one's tricky. All right, although you might have been tempted to say grouping because you notice grouping symbols, take a look at what's grouped, 15 plus X, 15 plus X. So they are actually grouped exactly the same. But what you should notice is the order is different. 15 plus X plus 2, 2 plus X, or plus 15 plus X. So my order is different. So that would be a green one. All right, how about G? And my apologies, somehow my dot got missing there. That was multiplication. So 4 times 1 equals 4. Identity. 4 times 1, any number times 1 is itself. That's identity. All right, take a look at H. A little bit trickier, but look at the details. Hopefully you can see order, X, Y, Y, X. So the whole thing would be true statement based on the commutative property. All right, take a look at I. I would be an example of associative. 3 plus 5 plus C, 3 plus 5 plus C, but what we notice is the groupings are different. All right, take a look at J. All right, hopefully this is good old distributive property, so one that you're more familiar with. 2 times 5 is 10, 2 times X is 2X. All right, take a look at K. Okay, a little bit tricky. You see grouping symbols, right? So you might be leaning towards the orange. However, my order, I still have X and Y grouped together, but my order is different. X comes first in this one, Y comes first in this one, so this one actually would be green. I take a look at L. If you said grouping, you are correct. Over here, 3x plus 7 is grouped. Over here on the right, 7 plus 4 is grouped. Take a look at M. This is an example of identity. A number plus 0 is equal to itself. N. AB equals BA. That's all about order. O. If we take a look at O here, we are looking at grouping. We are looking at grouping 7 and 3, 3 and 5, but we're all multiplying. You might have been tempted to say distributive because over here on the right it looks more like distributive, but when I look at the other side for comparison, it's just the order is different. Or I'm sorry, the grouping is different. All right, take a look at P. Tricky. You might be tempted to say grouping is different, but if I look inside those groups, I have the same thing added together. But what is different is my group plus 3, 3 plus my group. So my order is different. All right, take a look at Q. This would be distributive property. We have 7 on the outside of parentheses. Multiplying it through, we get this expression over here on the left. And last one, R. All right, R, hopefully you were able to see, although it was a little bit different here, we have 1x is equal to x. Anything multiplied by 1 is itself, right? So this time, instead of a number staying the same, it was a variable staying the same, and that is still also the identity property. So hopefully by going through these examples, you can see that they're simple ideas, but they can get tricky. So there is an assignment following today. So if you go under your Canvas page, under today's day of the week, you click on it, you'll find that there is an activity for you to complete. Now, the activity is not your traditional edit the work and send it back to me. You're going to need to, it's a picture of the assignment. So you're going to need to grab a blank piece of paper, number 1 through 10. Go ahead and work on the worksheet. I've also included a properties note sheet that you can look at that gives you, kind of these short and sweet definitions along with some examples to reference when you're completing it. But you're going to number 1 to 10 on a separate sheet of paper, write down your answers, they're multiple choice, and then submit your work via picture. If you need help, please let me know. You can send me an inbox on Canvas or a chat on Teams. All right, good luck.